number 9 on homework 1, which is associated with properties and equations of state and molecular level perspectives and phase diagrams. So homework number 9, we're now into chapter 4 on equations of state. And this is an equation of state problem. Specifically, it is 4.5, part A in Koretsky. So this is a conceptual problem, not a mathy problem, but it doesn't matter. Okay, so it says consider comparing 1 mole of ammonia versus at certain conditions versus a mole of neon. Now, what is neon? It's an ideal gas. Okay, so I have ammonia and I have neon, which is an ideal gas. Okay, at certain conditions, but I don't think the conditions really matter in this case because they're the same. Okay, same amount of moles, pressure of 10 bar, temperature of 500 K. Relatively high pressure, but also relatively high temperature. So that probably is an ideal gas. But the ammonia is also gaseous, but definitely not ideal. Okay. So answer the following questions using molecular arguments. Explain your choice with diagrams and descriptions of the interactions involved. Okay. Part A specifically says, in which case is the compressibility factor Z higher? So let's look at the math first. Z says PV over RT. All right. Now it says the pressure is the same, the moles are the same, PV over nRT. So same. The only thing that's different is the volume. So I'm really trying to decide which one takes up more volume, okay? Now, when it comes to which one takes up more volume, okay, now, ideal gas, Z equals 1, okay? And so I'm wondering, and the other thing about an ideal gas is what? How is an ideal gas defined? No interactions, no attractions, and no repulsions. So really we're looking at NH3 and saying, well, you have interactions, but are you more attractive or are you more repulsive? Okay. So we're looking at something good or are we looking at something bad? All right. So, but it's not, it's bad or good. It's when they look at each other, when I have 2 ammonias that look at each other, are they good or are they bad? Well, we've got NH3, so we're kind of doing a polarity shape thing here. So, if we look at it, we got we got H's down here, and we got, some lone pairs up here. All right. So, polarity is definitely polar. Okay. Degree, who knows? But it's definitely polar, okay? We definitely have some minuses up here and definitely some positives down there, okay? And minuses like positives and positives like minuses. So it has access to both. Now we're looking, and so the next thing we look at is hydrogen bonding. Well, yeah, nitrogen does hydrogen bond. This will accept hydrogens, okay? The last thing we're looking at is shape. Well, hydrogens pretty much don't take up any volume, so this is essentially a sphere. So we have a sphere that has a plus zone and a minus zone. We have another sphere that has a minus zone and a plus zone. I don't see anything about that says bad. I mean, those can line up pretty well. And it likes to line up. So we're going to say that ammonia is attracted to each other. And ammonia is attracted to itself. Now, if it's attracted to itself, what does that say about the volume? Okay, so let's think about it. You got 2 people who love each other and 2 people who can't stand each other. Which one's going to occupy more space? Like from head to head, like where the position at the head of one person, the head of the other person is. Are they going to be close together if they like each other, or far away from each other if they like each other? Are they going to be far away if they hate each other, or close together if they hate each other? If I hate somebody, really don't like them, I don't want to be next to them face to face. Now my wife, on the other hand, I love my wife. And she may not like me invading her personal space, but I don't care. I'm going to invade her personal space, and I'm going to be close to her. I'm going to be close to her physically, which means I'm going to occupy less volume. So, because they like each other, I have less volume. And because I have less volume, I have less compressibility factor.